So this is first video for linear, just a bit of a review of what hopefully you've seen before, so I'll go fairly quickly. Firstly, to plot points on a Cartesian plane, very important skill to have, relevant not just for linear but different units that we're going to study. We always start with our x value and then our y value, and we put it in brackets with a comma in between. So when I say the x value, it's how far to the right we need to go, or left, if it's left, or negative. So in this case, A is 3 units to the right and 7 units up. So 3, 7. B hasn't gone left or right at all, so we would put 0, but it's gone up 4 units, so our y value is 4, x value is 0. C, left 9 units, so we put negative 9, it's gone up 9 units, so positive 9. D, we've got negative 5 and negative 5. And E, 9 units to the right and 1 unit down, or negative 1 from there. If we were plotting these points, it's the same process. We get our x value to work out how far left and right we need to go, and y for our up and down. So F is going to be 1 unit to the right and 1 unit up, which is just there. Oh, I don't need that bracket there. G is 7 units to the left and doesn't go up or down at all, so it's on the x-axis. And H is 2 units right and down 6. So that would be 2 and negative 6. So make sure you're really clear on that. We're going to build on that in just a moment. I need to erase all this stuff. So here we're just subbing in different values for x and y and solving for our unknown pronumeral there. So it could be x or y. If we sub in x equals 0, we could write this as y equals 3 times 0 minus 2. 3 times 0 is nothing, so when x equals 0, y equals negative 2. When y equals 0, we end up with this. I am going to add 2 to both sides, which gets me to 2 equals 3x. And I'm going to divide both sides by 3, leaving us with x equals 2/3. Again, substituting 1 in this time for x. 3 times 1 is 3. 3 minus 2 is 1. Again, substituting 2 in for x this time. And 3 times 2 is 6. And 6 minus 2 is 4. So pretty straightforward again. Be careful with some of the terminology here. So this is saying that we're finding all the values between negative 3 and 3 for x. It's saying that x is greater than negative 3, but less than 3. That's what we're interested in for this function here. And then we want to sketch these linear equations from there. So let's have a crack at that. So when x in this question here is negative 3, we end up with negative 3 plus 2, which is negative 1. When x is negative 2, negative 2 plus 2 is 0. Negative 1 plus 2 is 1. 0 plus 2 is 2. And you can see a bit of a pattern forming here. So these all become different coordinates. Our x value is on the top, negative 3, and our y value on the bottom there becomes is negative 1. So our first point here is negative 3, negative 1, then negative 2 and 0, negative 1 and 1, 0, 2, and you can see a bit of a pattern forming here again. Alright, I'll try and sketch a straight line here. So because we're just looking at these points, that would be our linear equation there, but if it was just a normal linear equation, it could go on forever, and you would sketch it up to the extent of what you've got in your grid. The best I can do is a straight line here. Sometimes it's helpful to be able to rearrange different equations, so we're not changing the values of anything, we're just changing it so that it might be easier to see something or find something later on. And this first equation wants it in the form y equals mx plus b. We're making y the subject. So our first step would be to subtract 4x from both sides, which cancels here. We're then going to divide everything by 2, and of course cancelling on the left. And this is both terms being divided by 2. So 10 divided by 2 is 5, and negative 4 divided by 2 is negative 2x. So that's in the correct form now. This one wants us to do the other way, so rearranging so it's not y equals. First step would be to subtract 4x from both sides. And that's pretty good. You can leave it like that. It's in the form that it's asking for. But if we multiply by negative 1, we can cancel that negative, and it's going to change the signs on this side. So we end up with negative 1 plus 4x equals positive 7. So again, we haven't changed anything in the equation. We're just changing the way that it looks.